At this stage, what I'm going to do is to solve a question with you. I told you, and in the process of solving the question, I'll be giving you all the possible tricks as far as time series is concerned. And then, of course, you should also ask some questions in the process. Are you ready? If you are, just type yes so that I know I'm not alone. If you're ready, type yes. And then we can set a ball rolling. Okay. Ladies and gentlemen, the question, you all have it. You all have the question. So we're going to look at it together. This is a time series question. It has A part and then B part. The A part is like 15 marks. The B part is like 20 marks. Okay. Who will read the story for us? Normally, time series are a little bit like this. A few tricks, like this one. This one has a lot of tricks. Yes, Elizabeth.
Question 3. A Toyota plant at the East Coast region of US would want to forecast demand for a Toyota Corolla car next year using the data for the past 4 years shown in the table below. A related problem is the number of tires that must be ordered for the forecasted car demand, which includes 1 spare tire for each car. The plant has secured a contract for 100,000 tires for 2023. However, in case the number of tires required for the forecasted demand for a year exceeds the contracted value, it may have to trigger for a so-called orphanage scheme from the parent company to make up for the shortfall to avoid possible lost sales, which is estimated at $2,500 per car. The orphanage scheme, however, must be triggered at the beginning of the year.
So this is quite deep. And normally one of the things is that people tend to be looking into their books, even when it is 30 minutes to time. 30 minutes to time. The brain doesn't like that. You should never be looking into your books when it is 30, 20, 15 minutes to time, and then you are still flipping through papers. Whatever you learn at that stage will never happen, I'm telling you, because the brain is tagged. And so the brain needs time to relax. Whatever you've learned before, you can remember it once you are put into a thinking mode. Okay, so once invigilators are walking and passing by you, you will remember. Even if you've learned a week ago, you will remember. The human photographic memory is powerful. So get into the exam room rather earlier and then sit down. The exam questions are shared usually 15 minutes before the exam begins. That will help you to go through this question once, twice, 3 times, even 5 times. Fully get it before you start it. Okay. So we have the quarterly demand for Toyota. The quarterly demand are vertical. So every year, for example, in 2019, the first quarter of 2019, 4,800, Toyota Corolla cars were produced by this organization. The second quarter, the number came down. Then it went up in the third quarter because people are trying to prepare towards Christmas or so. And in the last quarter, it went even higher up. Okay. The same trend continues. Now, the moment you observe a table like this, one of the first things you do, even before you look at the questions, is to try and calculate the sum for each year and the sum for each quarter. That's the first thing you do. So note it down. You calculate the sum of, in this case, production capacity, the sum for 2019. You sum all the quarterly demand. And then when you take each quarter too, you get the summation. So I want everybody to calculate the sum. Calculate the sum horizontally and vertically before we even start. And when you get it, you tell me, oh, for this year, the sum is this. Or for this quarter, the sum is this. Once you got that, just unmute yourself and mention your answer. And remember, you always have something like that. So either it is in the form of a quarter or a season. Okay, quarterly demand or seasonal demand or something. It's in that sort of format. Who has gotten one? You should calculate. There's a deliberate hands-on thing I want you to do. I have done this hands-on. I always do. Hey, what happened? I've done this hands-on, and I always do this hands-on. I did my calculation. For some reason, I can't see it. Okay. Okay, Bernard, tell us what you have.
Okay, sir. So for 2019, we have 22.
Keep going. Don't
For
stop.
2020, 25.7. 2021, we have 27.5. 2022, we have 29.8.
Perfect. That's for the yearly demands.
Yeah, and then for the quarterly demand, quarter 1, 23.1, quarter 2, 21, quarter 3, 29.4, quarter 4, 31.5.
Thank you. Did you use Excel?
Yes, sir.
Never do it. Because the thing is that you see, the human mind doesn't like to think. That is why it thinks. And I asked you that because my mind tells me that's what you ordinarily would do. Because you might think, oh, I know I can do it. We all know we can do it. And we don't want to delay. But there is a particular reason why you got to do this thing. Because when you do it here right with me, you will make mistakes. So you'll be able to sort out, you befriend your calculator and make the mistake here than to make the mistake on that day. So learn to not depend on ChatGPT, because the thing is that these same things you are depending on, you will not use them in the examination hall. So I want manual computation. Eben, you follow?
Yes, sir.
Okay. Now, keep those in mind. So you've done the quarterly demand and the yearly demand. Now you need to get the overall demand. What was your overall demand? You should add all of them. Either you add them, vertically or horizontally. Deborah.
Sir, please, it's 105. 105.
Okay, good. Guys, if you are not doing some, do some. Confirm with yourself because I'm teaching you something that you should do well with it. But you should also know that you will make mistakes with it. And so you should do it and make mistakes now. Yes, Elizabeth.
Sir, please, doesn't mean we have to redraw the table.
No, you can choose not to redraw the table. You can choose to just write them, just write them whichever way you want to write them and put the total there.
Okay, thank you.
All right. The next thing now is, now that you have all this summation, the next thing you got to do is to go to the question. The question says, let SI and SFI be the seasonal factor. Now, originally, the question didn't say the seasonal factor, so I had to edit it. So when you get the original paper from your colleagues, you see that. So SI is a seasonal factor, and SFI is a seasonally adjusted demand forecast. Okay. Now, the SI is a seasonal factor for each quarter. Take note, each quarter. And the SFI is also the seasonally adjusted forecast for each quarter. Now, unfortunately, you will not be given the seasonal factor formula. The other formula will be given to you, even here, but you will not be given the seasonal factor formula. So you got to know the formula for the seasonal factor. Now, the formulas are down there, but the seasonal factor ain't part of it. Okay. Let me see. It's not part of it. So when you look here carefully, what we are seeing are the exponential smoothing, and seasonally adjusted exponential smoothing, all of those things. But it doesn't include that. So you want to be able to know the formula on top of your head. Now, what is the formula for the seasonal factor? It is given as SI equal to demand DI divided by the sum of the demand. Note it down. And of course, once again, when you write it down, you remember it. Okay. So this is a seasonal factor. What is that? What is that? What is a seasonal factor? The seasonal factor is telling you the contribution of each quarter's production, in this case, towards the overall demand. Like your first quarter, did you contribute a lot? Okay, then your seasonal factor must be big. And when you add all the seasonal factors, they must be equal to 1 because it's a ratio. As you can see, it's a factor. So we got to look at the question. The question says, it didn't say calculate the seasonal factor, no, but it said develop a seasonally adjusted forecast model. Okay, but then it will require that you know the seasonal factor. That is why I have given you the formula for the seasonal factor. Okay, the next one is not the seasonal factor, but then the seasonally adjusted forecast for each quarter. The I is representing that for each quarter. Seasonally adjusted forecast. Now, to get that, you need to multiply the seasonal factor you just got by the forecast. Now, the forecast is over time. The forecast is a time forecast. The forecast is for the time. You don't forecast for the quarterly. You forecast for the time. So once you have gotten the time, you can now add it. But of course, usually when you're starting, you don't know the time. You don't know the forecast for this period, the current period. You don't know the forecast. And so because you don't know the forecast, that's why the question is asking you to develop a seasonally adjusted forecast model. A model is something that has both numbers and letters. Okay, so he wants you to get him the model. But how do you get a model? The model will require that you have the value here for this. the SI, but you don't have the value for the other one. So you have the value for the SI, but you don't have the value for the FT. So it becomes what? A model. It becomes a model. Okay. So I just want you to understand the difference between these two. This is very, very important to me. The seasonal factor and the seasonally adjusted demand forecast. These two, understand it. If you don't understand, raise your hand. If you don't understand, raise your hand. It's better you understand something so well than to get so many things without understanding. Okay. So which one don't you understand? Belinda and Nana Kwesi.
So the difference between both.
The difference between the two. One is a fraction. It's like a weight. It's like a percentage. That's one. The other is an actual production, in this case, actual demand. So I can tell you that what is the percentage of money your partner gives you every month? And you will know that maybe some of the months, the percentage of the money he gives you in total is more than other months because there are Easter there, there are Valentine's there, there are, Christmas. So some of the months, the income will be higher. So you can now find percentages. Which month is the dominating one? Which month do you get a lot of income? Which month carries more weight? That's the idea here. Which month? And that percentage is calculated by knowing the amount you get divided by the total yearly amount. That is what we mean by seasonal factor or seasonal proportion or seasonal percentage, basically, or seasonal ratio. So that is the percentage or contribution of each quarter towards total demand. And then the seasonally adjusted forecast itself. That one is once you know this year, total demand, you can now multiply this percentage. Because once you know the total demand, you can now multiply this seasonal factor by the total demand, the total, not the total demand currently, but the total demand that you're going to use for the forecast. But of course, you also use this year demand to make it next year forecast. So the seasonally adjusted forecast model is that one that you use the proportion to multiply the total to get you for that quarter. So, because the thing is that if you want to really know next quarter how much I'm going to produce, I must know the total production. And then if I want to forecast how much I'll produce from January to, March, I need to know clearly, the total demand for now, because the forecast is dependent on the, yearly production. So the seasonally adjusted forecast is for the actual production forecast you're making. But this one, the seasonal forecast is just a percentage. Like, what is the weight I will attach to each quarter's production that I'll forecast? What is the importance? What is the weight? What percentage of that? So if your yearly amount of salary is 100,000, the question becomes, what percentage of that 100,000 is consumed in January? What percentage of that 100,000 is consumed in December? So you're able to know. Right now, so many people have consumed a lot of their yearly income. And so many people don't smile in January. Many people are angry. They are annoyed because they are consumed a lot of money as we speak. However, that is the percentage. That is the seasonal forecast. Does it make sense a bit?
Yes, sir. Thank you.
Okay, so now that you know this, we are going to calculate for 2 marks. We're going to calculate the seasonally adjusted forecast model. It's just a model we formulated. Okay. But to do the model, you need to find the SI. So now, everybody calculate the SI and tell me the SI. So SI means you should know the demand for that quarter divided by the total demand. Now, what was the demand for quarter one? What's the demand for quarter one? I mean, we calculated, haven't we? What is the demand for quarter one? You all have calculated. Bruce.
23.1.
Yes.
And what is the seasonal factor for quarter one? Bruce.
Okay, so it will be
Increase your voice.
0.22.
0.22.
Yes, please.
So that is a seasonal forecast. Who can tell me the seasonal forecast for quarter two? Who is talking a lot around the background like that? Isaac Otabo, are you really deliberately disturbing us, Ebenezer?
Oh, sir, it's not me.
Really? Okay, let me mute you and see. Yes, Susie.
Sir, please, are you doing the solution somewhere? Because I can only see the question.
The solution is being written on the screen, or you don't see the red writing.
Oh, okay.
But you have calculated, or you guys have calculated. That's why I'm only asking. Okay.
Yeah, please, how did you get the factor, the 0.2 something?
Have you calculated the totals here? Have you calculated the
Yes.
totals under each?
Yes,
What was your first total?
23.1.
So the S1 will be equal to 23.1 divided by the total of everything, which is 105.
10. Okay.
And you use that approach to calculate for each quarter.
Oh, okay.
So
Thank
you
you.
can tell me the next quarter. So this one is 0.22. What's the next one? Priscilla.
0.2.
0.2. Keep it all. Don't wait for me to be writing it before. So S2 is 0.2. What about S3? Linda.
0.28.
0.28. What about S4?
0.3.
0.3. So guys, these are what we mean by the seasonal factors. The seasonal factors. You take each one of them, the totals you had, okay, and then you divide it by the overall. Okay, so for example, the last one, it was the one that gave us this 0.3. It was 31.3 divided by 105. That is what gave us a 0.3. Very good. Now, the question says, develop a seasonally adjusted forecast model. So now that you've gotten this one, you can easily develop the model. How do you develop the model? You just substitute for each one the seasonal factor you just had. So the first one is going to be SF1 equals to 0.22 FT. That's it. That's the model. And then you do for the next one. What will be the next one? You can tell us the next one. Can be because that is refreshing your mind. If you are here and you know the answer and you are not speaking, you will see that you'll be bored. Very soon you feel even busy. And for those that are actually just listening and not participating, it's not going to help you much. As you can tell me for SF2.
0.2 FT.
Okay. I'm sure you can get that of the rest. Okay. You can all do the rest. So that's what gives you the 2 marks. Let's go to the next one. So the next one says, forecast demand for each quarter. Forecast demand for each quarter. This is a loaded question, but the reason why it's loaded is that it says using linear trend. Using linear trend for orders in 2023. So it means that you must know 2023 demand. or orders. Orders is the same as demand. You got to know that. But we know 2019 demand, don't we? Who can tell us the 2019 demand? What is the 2019? Yes, ma'am.
22.
22.
Okay, so you see, those were the ones you wrote on the far end there. What was the 2022 demand?
25.7.
25.7.
Demand is 29.8.
So
29.8.
29.8.
It's
It's good.
29.8 dog.
It's 29.8.
29.8, yeah.
It's good she's gotten it wrong, because if she had relied on her brain that, oh, I can do it, she would have known that that was wrong. Okay. It's always good to work it out and then to get it. And of course, sometimes I deliberately write what the person is saying. I don't correct it until all of you have corrected it. So that is 29.8 and not 25 point. So we need to get that of 2023. That's the point. But we can't get it unless we use a linear trend line to forecast for 2023. Wow. How do you do that? Well, to do that, you need to create a regression. You see, it requires a sort of a regression. That regression requires your X value and then your Y value. Your X is time. Your Y in this case is demand or production here. So what are the X's? Who can tell me? The X here, what are they?
They are 1, 2, 3, and 4.
Fantastic. 1, 2, 3, and 4. You have to write it in your book like that. And what are the Y's?
Y's are 22,
22, good.
25.7,
25.7,
27.5,
27.5.
then 29.8.
So guys, you should be writing these down. And that's why it's 6 marks here, because there's a lot involved there. After you've gotten your X and your Y, yes, Belinda.
Please, for the X's, when you say time, are we considering the number of quarters in a year or the number of years for which the
Period.
production was given?
Period.
Sorry.
Period. Period. Each year is year 1. So
Oh.
you're just climbing up. It's there. It's there. The period. This one. That's the X.
Okay.
It's always given to you. All right. So once you have the time as well as the demand, to be able to create your linear trend line, first you need to have the linear trend line. And what that means is that you need to have a regression equation. That's what it means. So you need a column, another column. What's the name of that column? What's the name of that column?
The XY.
XY. And then after that, you need another column. What's the name of that another column?
X squared.
X squared. Now, question is that how would you know all of this? Well, you have to look at the formula that has been given to you. And here you will notice that this formula 12, it has the slope of the regression. What's the slope of the regression line? And because it has the slope of that regression line, what happens is that you need to look at the content of that formula. Okay, many people don't look at it. This is the XY. That is the one I have here. And then you have the X square, which is the next one I have here. The rest are easily obtainable as we go further, because the X here is the mean of the X. The Y here is the mean of the Y. And then this X square bar, X bar square, is just the same one at the top, which you are trying to square it. And in this question, the examiner has even been helpful. He shouldn't tell you that there are 4 periods, because you should know automatically that there are 4 periods. Okay. Now, what do? You take this one here. Let me just undo this. And then you fill in these numbers. This is where if you make the least mistake, you get everything wrong and you lose everything too. So you take your 1, you multiply by the 22, that will give you what value?
22.
22.
That will give you 22. Okay. So you will have your 22 here. The next number is what?
51.4.
51.4.
Followed by
82.5.
2.5, followed by
119.2.
You see, if you have calculated it, it's a whole different ballgame. Just check it. This will take time, but you gotta supposed to finish this within 45 minutes. But it takes time, believe you me, especially when you have pressure on your neck. Now you go to the next one. Requires that you square the x's. So the first one will be what?
1.
Next.
4.
Next.
9.
Next.
16.
You gotta be so quick in giving those answers as you go. Yes, Susie.
Please, the 4 is 29.8.
But it's 29.8.
Oh, okay. I see 25.6. Sorry.
Okay. So once you've gotten these, you now use the formula to be able to come out. Now remember that the formula for the trend line, that is for those of you who may not know. Let me just go back here. The formula for the trend line is always given. That is what you see in equation 11, the A part. The A part was achieved by manipulating the Y. So technically, it is Y equals to A plus B, X. Okay. That's usually the case. The next one now is use that formula. Now, how do you get? First, you got to find the B. This is the one we are looking for first. Daisy.
Well, I always ask why there's a bar on top of the Y and the X.
Here in equation 11.
Yes, please.
I've not gotten there. When I get that, I'll tell you.
Okay, thank you.
Okay. So now, the formula that you're going to use to find the B. So our goal is to find the A and the B, but then find the B first. Because once you find the B, it helps you to find the A. The B is the intercept. Okay. It tells you how demand is changing over time. That's basically what it's doing. How does demand change over time? So with this, all you got to do is to find the B, and the B is the formula down here. Okay. So you just have to take the summation of each of these. That's it. You sum each one of them, because the thing is that each one of them will have to be summed to be able to get to some other part. So let's take the first one. X, when you sum them, what do you get?
10.
The next one, when you sum them, what do you get?
105.
105. The next one, when you sum them, what do you get?
275.1.
This one,
275.1.
your calculator must be your friend. And the last one?
30.
Good. So those are the information now you need to calculate the B. So now that you have this information, you now get into the mood of writing your B. Now, how do you do that? Well, as you can see, it's right here. So you just write the first one. If you check the formula, the first one is the 275.1. So you're going to write 275.1, okay, multiplied by 4. So you put the 4 into bracket. Now, why do I say 4? Check it. When you look at the formula carefully, it says that you are doing it for each one of them. Okay, I'm doing it for each one. So I do x times y, and then I sum them up. I sum them up. Hold on. Hold on. No, it's just 275.1. That's all. Okay. It's just 275.1. This is it. Okay. So it's just 275.1. Then let me just delete this before. Then if you check the formula carefully, the formula says there must be a minus n. Minus n. So you do minus n. N is 4 into bracket x bar. X bar is the mean of the y. The mean of the x, which is what you have here, 10. So you slot that, the mean. Oh, sorry. The 10 is the summation, not the mean. So x bar is also there. X bar is equal to the mean of the x divided by the sample. Write it down if you don't know. That is x bar. X bar means the average. The average. The average. And so we know that the sum is 10. And then the sample size is 4. So it becomes 10 by 4, which is 2.5. So what you are going to write here is 2.5. That is for the n that you see. Then, so that is a 4 multiplied by the x bar, which is around 2.5. We calculated. Multiplied by y bar. Y bar, as you can see here, is 105 divided by 4. Okay. So you also, once again, substitute that. 105 divided by 4. What do you get it?
26.25.
26.25. So you substitute that into bracket, you have 26.25. So that's the numerator. You divide that by the denominator. Denominator, the first one is a sum of x squared. The x squared we already know. Okay, here. Sum of it is the 30. So you write the 30, which is this one down here. Then minus the sample size. Okay. Sorry. Is it a sample size? The formula is what? Minus, yes, n, the sample size, which is 4. So you write 4, then the x bar square. That is the mean of x. So you write 4 multiplied by the x bar square. The x bar is the one we just found here, 2.5. So it becomes 2.5 and square. Job done. If you should calculate this well, just go step by step. Respect your calculator. When you calculate this very well, what would you get? I was delaying so that some of you will calculate.
2.52.
Exactly.
10.05.
No.
2.52.
2.52. But it's good you've gotten it wrong here. See, that's why I like it for you to calculate. It's 2.52. So sometimes when you're multiplying, when you're adding, when you're bracketing, you got to check all of that. So if you do it well, you're going to get B to be 2.52. Now that you've gotten the B, you can easily get to the A. Because when you look here, okay, when you look at this formula here, to get the A, you move everything to the left-hand side. And when you move them, they become averages. So you get Y bar, because Y is already on the far left, minus B X bar. So the Y and the X's becomes average, equals to the A. And we know that the B is 2.5. We just found that. Okay. Those of you are disturbing. When people are not paying attention, that's when I know they will disturb. You see that the person is chatting with the children and all of that. And then the person will bring the disturbance to us as well. So what you do is that you get your Y bar. Your Y bar is going to be, what value is that? 30? No, not 30.
26.25.
So you substitute that 26.25 here, then minus, then B, then X bar. X bar is what? 2.5 equals to A. So when you work it out, you're going to find A to be what value?
19.95.
19.95.
So now you have your 19.95. You can now write the entire equation. Let's write the entire equation. Okay. I want to write the entire trend line equation. So the equation is going to be Y equal to the 19.95, that is the intercept. Okay. And then plus, because the B was a plus, not a negative. Plus, oh, it was a minus. No, it was a plus, yeah. Plus 2.52x. So this is the equation. This is the equation. What does the x stand for? It stands for one of the time period or the year. Okay, so that is the x. The x. So we can now go back to the question. Let's go down to the question and then address key thing the question is trying to handle. Yes, let's go back there. The question says, forecast demand for each quarter. Forecast the demand for each quarter. How will you go about it now? Now that you have before you can forecast demand for each quarter, you need to know the demand for the year. We don't know demand for 2023. So to get 2023, we got to substitute Y and write 2023 equals to 19.95 plus 2.52 into bracket what? You can tell us.
5.
5. Because that is the fifth period we are dealing with. We have period 1, 2, 3, 4. So the period we are trying to forecast, demand for is 5. So you substitute the 5, and then when you do that correctly, you're going to get 32.55. Check it. So that is the demand for quarter 5. But that is not for the quarterly demand. Okay. So now, if I want the quarterly demand, you remember the quarterly demand was given as SI, where I is for the period. So S1. And what did we say? No, that was a forecast demand. But then what we are being asked to do here is it says forecast demand for each quarter. Forecast demand for each quarter. So you have to take the seasonal factor. I don't even know how to write it, but you get what I mean. You have to take the seasonal factor. I'll give you the formula. Forecast demand for each quarter. I think we call it, it's rather like this. It's S, F, I equal to, what was the name? You guys remember how I wrote it? It was up there.
0.22.
No. The 0.22 is what? Is a S, right?
Yes, sir.
And then
SI times F. Yeah.
That's what I'm looking for. Okay. So you got to know this formula. You got to know it. You got to know it all, so that it guides you whenever you're writing. So now that you know it, you can now what? Write SF1 for period 1 is equal to, then you take your 0.22 and multiply that by the one you just got, the yearly one, because that is a forecast for the current period, which is 2023. So that is what? That is 32.55. You do that and solve for the quarterly demand for the first quarter. The quarterly, okay, the seasonally adjusted forecast for the first quarter. What do you get? You get
1.61.
716. And then you do the same thing for the second one. See, what I'm talking to you, I'm also calculating. So it becomes 0.2. I think that one was 0.2 times the same 32.55. And that would be equal to, what did you get?
6.51.
6.51. You see the way you are mentioning it, somebody is sleeping. SF3. I like it. See,
Sir, please check your SF1. It's 7.161. You wrote 7.716.
Is that it for all of you?
Yes.
Yes.
161.
Yes, it is 7.16.
Yes, please. 7.161.
Okay. So you get 0.28 times 32.55. That's the third quarter. That should be, what do you get? 9.1.
9.114.
And then the final one is SF4 for that quarter. That is 0.3 times 32.55. Remember, you need to know this yearly one before you kind of multiply it by the seasonal factors you had to get the seasonally adjusted forecast. What do you get for this?
9.765.
9.765.
9.765.
Good. So these are the quarterly demand. So by the time you get here, you've gotten 6 marks as well into the basket. Don't say that, hey, this all this percent means. That's it. Yes. Ashla.
Yes, Doc, please. I wanted to ask, with the last one, the 9.765, do we approximate the 6 to make
No.
it 9.77?
Just use all
Because
of them.
the question said we should leave it 2 decimal places.
This one, it didn't say that you should leave 2 decimal place. If it did, it does say it, yes, leave it.
By approximating, or we just use the 6 without the approximation.
What do you mean by without that point? If you are rounding something, you round it well, isn't it?
Yes, Doc.
So you can't say that you just use a 6.
Okay, thank you, Doc.
Yes, next. Next person.
Sir, please, where you have the Y 2023, I got a little lost on how we got the 5 for the X. If you can please clarify that for me.
5 is the period 5. Remember the quarters were 2019, period 1, 2020, period 2, 2021, period 3, 2022, period 4. And we are going to do for 2023. That's period 5.
Okay. Thank you very much.
Right, you're welcome. So that is how you address this seasonally adjusted forecast question. Yes, Belinda.
Please, for the why are we using that of year 2023?
Because look at the question. The question says forecast demand for each quarter for 2023 using trend line forecast estimate for orders in 2023. So it's a question that I was asking.
Okay. Thank you.
You should have the question in front of you. Don't only look at my screen. All right. Now we go to the one that will give us 10 marks. Add to the terminal. What is this is the tricky part, okay? What is the number of car ties needed to meet this forecasted demand in each quarter in that 2023? We need to know the number of ties needed. But the story actually told us something about ties. Let's go up to go and read it. What did it say about ties? Who can tell us something is said about ties? Because you must have a fair idea. According to them, when you look at the story, each Toyota Corolla requires how many ties? In total, how many ties?
100,000.
No. Each. I didn't say the entire plant. Each.
Say five.
Why not 4?
Say because it says it includes 1 spare tire for each
Exactly.
car.
You see, that part is the part where the smartest are separated from the smart. So the question was very explicit. It says that in the case the number of tires required, blah, 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 a year exceeds the contract, it may have to blah, blah, blah. Then it says that a related problem is the number of tires that must be ordered for the forecasted demand, which includes 1 spare tire for each car. So because it includes 1 spare tire, we have 5 tires for 1 car. Okay. So you got to read through the question all the time to pick out the few details. So the question says, what is the number of car tires needed to meet this forecasted demand, not for the year, but for each quarter? So first of all, we know that we have 4 regular ties plus 1 tie, making 5 ties. Now, the forecasted demand for 2023 itself is in thousands. Don't forget. So first, we need to get the forecasted demand for each quarter. How do you get that? You have to take the 5. So this is how you calculate it. Just follow me here. Because this is where the difference comes with some other people. Okay. So if we are doing it for 2023, okay, you have to take the X, which is a period, or basically, no, not a period, but the X representing the number of ties, multiply that by the seasonal forecast. Okay, the seasonal, because the question was about forecasted demand. So multiply that by the forecasted demand for each quarter. So write SI, because that's the forecasted demand for each quarter. Then you multiply that by 1,000, because it was measured in 1,000. Now, let me just remind you do you know for each quarter we were able to calculate the forecasted demand? Do you remember? When we multiplied each one by the 32 for the year, if you can remember, we took the 0.22 times 32.55.
Yes, sir.
Yes. Those ones that we did, they were the forecasted demand for each quarter. So the first one we had 7 point, I think I wrote 716.
161.
161. And then you said it's what? No, I wrote 716 and he said it's 161.
Yes, sir. Yes, sir.
So that one, then the second one was what?
6.51.
6.51, then 9.115, then 9.765. So those ones are the SI. Those ones are the SI. So you're going to take the year, well, not the year, the number of ties, which is 5. So for the first quarter, it's going to be 5 times 9.161, I think, multiplied by 1,000. That would
It's
be
7.161.
7.161.
I was trying to be sure that you are all following. So now you are actually following. So do that and tell me the value for each of them. Tell me, because the question says, what is the number of car ties needed to meet the forecasted demand for each quarter? So for each quarter, how many ties do we need? For the first quarter, how many ties do we need?
35,805 for the first quarter.
Yeah, what is it?
35,805 ties.
35,805
ties.
Did you all get that? Yeah. The second one,
Yes.
Yes.
second one will give you 32,000. You can tell us the second one.
550.
32.
Very good. So that is a number of car ties needed for quarter 2. What about quarter 3?
$45,570.
Very good. And finally, quarter 4 will be 48,825. So by the time you finish calculating all of this, you get that extra 2 marks. Isaac.
The formula, I want to ask whether is it XF1 or X1, because the X1 is 0.22, 0.2. So if you said X times X1, I don't understand it clear.
It is a SF1, actually.
Okay.
It's a SF1. It's no one, actually, SFI. So that to be for each one of them. Any other question on this one? Any question on this very one? So you see, it requires that the person has this latter part of questions you're actually looking at requires that the person has a deep understanding of what is going on. Because honestly, if the person doesn't have a deep understanding of what is going on, that person will not be able to answer this very part. But hey, you are all smart, so you can do it. Next question. Will the plant have to trigger the orphanage scheme? Again, this is understanding. Will they have to trigger the orphanage scheme? For you to be able to appreciate this question, you need to go and read the question and see the connection to everything regarding the orphanage. What did he say about the orphanage? Well, there were 2 places that orphanage point was mentioned. The first place was this. Okay. And then the second place was that. So you have to understand the perimeter of the sentences there. It starts with however. So what does that mean? What are they trying to say? This one, you got to read it like, when you are in a class, you got to read it like 4 times to make sense of it. What does this mean? You can tell us. However, in case the number of ties needed for the forecasted demand for a year, in case those ties exceed the contracted value. What was the contracted value? What was the contract? 100,000. 100,000. In case the forecasted demand is more than that. So you see, if the person doesn't know the contracted value or better. But if it is more than that, hey, so we are going to the cars that we need, that we are forecasting that we need, is more than the one that was in the contract. then it can bring about an orphanage scheme from the parent company. Why?
1,750.
Now, why do you think they even have to bring about this question? They need money. They need money to do something. So the parent company will have to make up for the shortfall. Because you have made a contract, okay, that you want 100,000 of something. But then when you did the analysis, you realized that you needed more. But that more, no, the extra was not in the contract. So it means that you have to find a way to top up that income. You have to find a way to be able to meet the amount of, so whatever money you had intended to use, you had some money you want to use, for an orphanage or something, you have to go and take that money and use it to beef up this. The orphanage scheme must be triggered at the beginning of the year. It's not at the end of the year, which is the interesting part. Okay, so how do you incorporate this into your analysis? Well, first, the total number of ties needed in 2023 are how many? We need to find that. How do we get that? We have already calculated for each quarter, haven't we?
Yeah.
Yes.
So we can take the
Yes.
total number of ties we have for each quarter and do what to those numbers?
Add.
And
Add.
now
Very good.
162,750.
750.
Hey, what's it?
So
I've done it already.
162.
162,000.
750.
750.
Yeah.
Yeah. Somebody is sitting down. The person said, "Dear Namokikan." But that is exactly what they are saying. So that is the first part. So now we know that the total number of ties we need that whole year after adding the quarterly production. Yes, Belinda.
Please, I'm lost.
You will be clear with which one you are lost. Ask a question. Don't say I'm lost.
Hello.
Yes, ask your question to define your meaning of loss.
With fourth the fourth question that we were talking about.
What was the question?
So would the plant have to trigger the orphanage scheme?
Yeah.
Yes,
But
and
we
I'm
haven't answered
hearing
the question. We are building a case.
Oh, okay. I heard some numbers, but I didn't know where those numbers were coming from.
What will make the plant to trigger the orphanage scheme? If demand or production is more than the contract, isn't it?
Yeah.
The contract is 100,000. If we go and check the number of car type production, and it is more than 100,000, it means that we need to bring some money from somewhere. That is what is going to trigger the orphanage scheme. There's some money we have that we want to put into an orphanage. Then we got to bring it out. We got to cough out that money to be able to meet the demand. But first, we need to know the total demand for the year to see whether it's more than the contract. Are you listening?
Yes, sir.
Yes, sir.
What was the total demand?
1,750.
What was the total demand for the year 2023?
162,750.
So now that you have that total demand, is it more or is not more?
Yes, it's more.
Okay, so question: would the plant have to trigger the orphanage scheme?
Yes, sir.
Why?
Yeah.
Because
the total demand is more than the contracted value.
Exactly. So yes, the plant must trigger the orphanage scheme. Because the forecasted demand in 2023 requires 162,750 ties. That's what we need. And this is more than the 100,000 contractual agreement. More than that by how much? It's more by how much?
62,750.
62,750. Yeah. So that is huge, huge, huge number of ties. Now, if we don't secure this 62,750, what will happen? If we don't secure these additional ties, it will result in a substantial loss.
Yeah.
Now we need to calculate the substantial loss because they gave us something, if you can remember. They told us that anytime you don't get the extra, you will lose amount of money. Do you remember?
Yes.
Read the question here.
2,500.
2,500.
2,500.
You see, if a question is like this, if somebody doesn't bring your attention to the nitty-gritties of the question, you look at the question like that. So you got to normally read it. I can promise you the only way sometimes of handling is reading it multiple times. Don't just submit the paper and say, mabre, and you're by force. No. So watch it. You got to read this thing 15 times in the exam room if you don't get it. It says that it will have to trigger for a so-called orphanage scheme from the parent company. You see, that parent company, theirs is to be building orphanages. It's like philanthropy. But now they need to get that extra 62,750. They need to get it back. So it will make up for the shortfall to avoid a possible lost sales because they need to make sales of the cars. But in order to avoid a loss scale, which is estimated at $2,500 per car. Remember, it's per car because once you don't get the tire, you can't sell the whole car. That is why, the cost of the car itself is sort of connected to the tire. Yes, Belinda.
So this one they're terrible, but I don't know if it's just me, but sometimes when you speak, it's like the network keeps going on, so I can't hear some of the words you are saying, and it's confusing me. The 162 something, how did we get that?
Have you written it down?
I don't even know how we got it, so I don't even know how to even write
No,
it down.
listen, my dear, you don't know how we got it, so you decided not to write it down, even though they said it many times. Is that how you learn? That you don't know how we got it, so you won't write it down. We have explained how we got that 162,000 for all this while. We added the quarterly demand up to now. Now that we've gone ahead looking at orphanage issue, how we got that 162, remember? Yes, Abdul. Abdul.
Yes, okay. I was going to ask how we got the SF1 because then I was using 7.71, but I realized 7.16 instead. So I'm okay.
So
sir.
you are sorted.
Yes, sir. Thank you.
Yeah. Belinda, you know how we got the quarterly demand, the quarterly forecasted demand?
Yes, I do.
What were the values? Tell me the first quarter.
The 3,580.5. Okay.
Did you say 3,000?
Oh, sorry. That's for the first quarter, I got
I think you haven't been
7.161.
paying attention, Belinda. You know yourself. You haven't been paying attention, and you should have asked at that time. And now that you can see that because you didn't pay attention to the earlier one, you are missing the current one, and that's when it's piling up. So when you are stuck somewhere, slight stuck, you should say it. Not when we have gotten far. Otherwise, you take the whole class backward, and they don't like that normally. Yes, Abdul, is your hand still up?
Sorry, it's the earlier one, sir. Sorry.
Okay. So go over this in the recording, and then you should be able to get it since you didn't write them down. All right. Now, would the plant have to trigger the orphanage scheme? So that's the one that we're looking at. And we've all come to the agreement that once the amount of, what's the amount to? The amount of 162,750 ties is more than the 100,000 that the company, the Toyota company, has been contracted to collect. It means that they need to fill in that extra, that other part. Okay. And how do you do that? That 65,000, we said that the money they have decided to use to build an orphanage or something, they need to bring that. Now, each car requires how many cars? How many ties?
5.
Good, 5. But now we know that, listen carefully, we know that the 162,000 is more than the 100,000 by 62,750, Abby.
Yeah.
Okay. So we know that each car needs 5 cars. Sorry, 5 cars. Each car needs 5 ties. Now there is 62,750 ties to buy. But each car will need how many of these?
5.
5. So how many cars need this?
12,550.
12,550.
Again.
12,550.
Yeah. The rest, teach them how you got it.
So we divided the excess of 62,750 by 5, and that gives 12,550.
Good. You see, this 550 that we just said, if somebody doesn't understand, this is the time you say you don't understand. Not when we have gotten to subsequent ones. Yes, Oshila.
Sir, please, the explanation he just gave, I think the line was breaking at my end. I heard him saying to divide the
So
subsignificant
we
number.
needed 62,750 ties. And each car will need 5 ties. So how many cars? We need all of these total cars, total ties. You just have to divide this number by the 5 because each one car needs 5 of these ties. And when you do this division, according to your friends, you get 12,550.
Okay, thank you.
So what it means is that, I mean, if you have a clear, the next question is even automatically answered. So it means that if the orphanage is not triggered, okay, this 12,550 cars cannot be what? You can tell me. Cannot be what?
Cannot be sold.
Cannot be sold. We cannot sell, we cannot produce these cars if you don't trigger the orphanage. And that would lead to a loss in sales. And we can calculate that loss in sales, can't we?
We can.
Yes, we can.
How much loss in sales are we going to incur now?
21,325,000.
If you don't come anymore, cheaper. Say it again. Before somebody come and ask me how much million?
31,375,000.
Yes. 31,375,000
USD.
If you are here and you have a question, ask your question.
Hello,
Yes.
sir.
Yeah.
Sorry, my line got cut. How did you get the 31 million.
Okay. So we were told that anytime, this again is from the question. Okay. If you go back to the question here, you see this number here on the screen, US dollars is 2005. Anytime you don't sell even one car, this is how much you are going to lose. Okay. Anytime you don't sell one car. And now we need about 12,000, as you can see on the screen, 12,550 ties to be able to sell 12,550 cars. Sorry, we need 62,750 ties here, divided by 5, to be able to sell 12,000 cars. If we don't sell one car, we will lose this amount of $2,500. If we don't sell the second car, we lose $5,000. If we don't sell the third car, we will lose $7,000. Are you getting the point?
Yes.
So if I want to know the total amount of money we will lose if we don't sell all the 12,550 cars, you multiply the 12,550 by the 2,500. Are you following? So you have 12,550 cars multiplied by $2,500. This is the amount of money we are going to lose if we don't sell those cars because we didn't get the ties. And that is why we got to activate the orphanage, the money there. Got to trigger the money that we have put into the orphanage. Does that make sense?
Yes, please.
So,
thank you.
if you look at this latter part of the question, will the plant have to trigger the orphanage scheme? You all can say yes, but you got to say yes with a numerical statement. Now, so that is the part that we've just gone through, using that for 30-something million to indicate, yes, we need to trigger it, else we are going to lose that money. You see, it's very, very interesting to know that you have the car's radio, but you are waiting for ties. But the ties are not coming. And because the ties alone are not coming, your car is not sellable. You produce the cars already in the hope, projection-wise, that this will happen. Okay. Now, suppose the Toyota plant decides not to trigger the orphanage scheme. The money is not for a joke. How much money would the plant lose? Do you realize we've already calculated it?
Yes.
Yeah. So you just write that amount of 31 million. You don't even need to do anything. We've already calculated that. That is how you attack this kind of question. Any question on this? Of course, the most important part of this is your ability to calculate the seasonal factors. Don't forget the SI. Okay, either in the form of a model or whatever. Then, in order to get this seasonally adjusted forecast, you got to use a linear trend line. And the linear trend line requires that you have an X and you have an Y. The X is always the time. The Y is usually the demand or the production or the sales, something. Once you have these two, you can find your XY, the X square, and then use the equation of a line formula to find the B, which is the slope. Once you have the slope, which is the B, okay, you can find the intercept, which is the A, which is given by the Y bar minus the B X bar. Once you have the A, you can now rewrite the entire equation, A plus the BX. Once you write the equation, you can now substitute the value of the next period. And the next period can be period 5, like what we have, or period 6, or period 7. In fact, you may be asked to calculate, what would be the forecast demand for period 8. It doesn't matter. As long as you have the equation, you can calculate any period. And once you have that period, you can find the quarterly, forecast demand for that period, for that year. In this case, the year was 2023. So now we can go and then find for each by using the formula, which is known as the SFI formula. So we now take each seasonal factor, multiply by the forecast FT. That formula was this. I'm just recapping. SFI is equal to SI times FT. FT is the one you calculated for the whole year. So you now multiply each one by, because each one has got this percentage, and then that will give you the seasonal factors. Once you got that seasonal factor, in fact, usually there are other questions that can be asked, okay? Not just this one. For example, after this, you can be, I think we are going to go through that. After you've gotten that, there are other questions. In this very example, there were other questions that were asked. Sometimes it can be asked like here, Sometimes it can be something else. These other petty things, if you know how to calculate what we have just done, you just have to think small. And sometimes you don't have to bury your head in the question paper. You just have to raise your head and look at other human heads in the room, because it reminds you that it's human beings you are with. And then once you do that, you stretch small, you can even go and wee-wee. And then your brain is now opened up again. Okay, we're done with that. Any question on this? Let's
Hello,
look at the
Doc.
yes.
Please, I'm asking the question. We are done, but I wanted to ask, you see the side where you pick the XY, which is the 275.1, that formula where we put the numbers in it. Like, I'm taking you back.
Okay.
Yeah,
So
I
I
was
should go
wondering
back.
why. Yes, please.
Okay, I'm back.
I'm wondering why we picked just the 2751.1, and we didn't pick the other, like any of the other totals.
Which 2751?
Okay, let's move on.
Yes, Mercy.
Okay, so me to that same formula. Please, I want to understand the denominator.
Yeah.
Read the formula.
The one she just spoke about. So I'm talking about the denominator, the 30 minus 4 into bracket. The bracket, I didn't get it.
The B formula.
The B formula.
The B formula, yeah.
Oh, the B formula there. Let's go down. It's a formula that is down here for equation of a line. Do you remember y is equal to mx plus c?
Yes.
That m is the slope, and that is the same as the b.
No, so for that one I get it too, but the very long one that we found the b.
Let me go down. This one.
Yes. So
your question is
the XTYT. Why did we use the 275.1?
okay. So
Is it
what
like
we
total of
we
XY?
we got x and we got y column. X was 1, 2, 3, all the way to 4. Y was some numbers. Then we got your xy and then x squared. And then we total each one of them.
Yes, please.
This one is total is this one.
Yes. Oh, okay. But why is T there?
It's indicating that it's over time, Keke.
Okay.
It could have been written simply without a T, but just xy minus nx bar y bar, divided by, of course, you have to bring the summation, divided by sum of x squared minus nx bar squared. That's all, without a T.
Okay, now.
Sir,
Sir,
please,
please,
on that same one, the B, the n minus n x mean of x squared. The x squared, the mean of that is 7.5. If I'm not mistaken.
Mean of
The
what?
x squared, x squared.
Yeah, but I didn't write that. I only wrote the 4, then I wrote 2.5, then I squared it. So yes, when you square it 2.5, you get that.
Oh, okay. All right. Okay. All right, sir. Thank you. Thank you, sir.
Any other question? It's good to crack these petty things. Yes, ask me.
Doc, please, good evening. Please, I just joined because I didn't have light, but I wanted to ask a question about the simple exponential smoothing. I don't know if I can ask now or I should
We're
wait
about
till.
to do that.
Oh, okay, sure. Thank you.
Okay. So now let's go back to the next part of the question, which is the next part is here. Somebody should read.
the enrollment of the EMBA program at the University of Ghana Business School for the past 6 years is shown in the table below. Develop an adjusted exponential smoothing model and compare to a linear
You didn't
trend
mention
line.
what is in the bracket. They are not important.
Okay, develop an adjusted exponential smoothing model, alpha equal 0.30, beta equal 0.20, and compare to a linear trend line model of exponential y equal 459 minus 17.46 times AT based on the forecast accuracy of the two by using MAD. Indicate which forecast
It's accurate.
is accurate.
Okay.
Assume F1 equal D1 and T2 equal 2. 11 marks.
Yeah. And I think your question about simple exponential smoothing will come from here, Abby.
I think so, but or should I ask so you?
Yeah, I think because this one is adjusted. So let me hear of what you
Yeah,
want to
these
say.
are okay. So in the YouTube video, right, the PM computers, you know you mentioned that the forecast for the current period is the same as the demand for that period. But I realized that when we are starting for January, if January is the first month, the
It
forecast
can
we
change.
put zero.
I say it can change. It depends on who is giving you the question. I can give you and say that the forecast for the first period is equal to that of the second period. I can
So
give
I
you.
don't know if it's the terminology, but I realized that if maybe we are solving for the second period, for the first period, we actually use the demand that the question was given. At
Yes,
when we are
F1
at
is equal to D1.
yes, but when we are at that period, so let's say for example it's January, the answer you put there is zero. So I was wondering why.
You're talking about something in the past which I've not seen. So maybe we should solve this one.
Okay, sure.
Maybe so. Say if it's so, no. Okay. So you have year and enrollment. This one is enrollment of EMBA students, okay, for the past 6 years. And you are to develop an adjusted exponential smoothing, which means that you must know the smoothing factor and of course its corresponding dampening factor, as well as the beta. Now the smoothing factor is the alpha. The beta is the smoothing factor for the trend. The smoothing factor for the trend. But the alpha is a smoothing factor for the level. That's where you learn. Because if you have not mastered those ones, the smoothing factor for the trend, and then the smoothing factor for the level. So alpha is the smoothing factor for the trend. For the levels. And then the beta is a smoothing factor for the trend. Now, let's remind ourselves of these people. Okay. Now, first of all, before you can actually calculate the adjusted exponential smoothing, you need to know the simple exponential smoothing. Are you guys aware? You need to know the simple one. And the simple one requires a formula. Do you remember the formula for the simple exponential smoothing? Well, it's down here. So you can always squeeze yourself down here and then be able to crack that. That is equation number 8. So you might want to write it down. Equation number 8 is the simple exponential smoothing. Sorry. Yeah. The simple exponential smoothing. Or another way of saying it is that exponential smoothing forecast, a simple exponential smoothing forecast. But sometimes you don't need to bring the simple. Once you say exponential smoothing forecast, it is a simple. Okay. So what is the first part? You can tell me what the first part is. The first part is forecasting for the next period. Then you have alpha. Okay. Alpha is the weighting factor, what you call the smoothing constant. The smoothing constant. And D is the actual demand presently. Actual demand. And then 1 minus alpha, alpha is the dampening factor. Dampening factor. And then the FT is the previously determined forecast. The previously determined forecast. And I'm just giving you this. You should be writing them because the more you write them, there's an information symmetry between your fingers. Yeah.
Doc, please, if you could go over again, the alpha,
okay. So the FT plus 1 that you see is the forecast for the next period. Can I continue?
The
FT plus 1, that is a forecast for the next period. The alpha is the smoothing constant or the smoothing parameter. Okay, that is, and the alpha is given to you here. In this case, it's 30%. So that is a smoothing constant. If you are not writing, you are in trouble because it means that you are not really, your mind is not fully engaged. Okay. The DT that you see there is the actual demand in the present period. The T attached to it, the subscript T means it's in the present period. The T plus 1 means in next period. T minus 1 means previous period. That's how it works. Okay. Then the 1 minus alpha is just whatever was in the alpha. So if the alpha is 0.3, the 1 minus alpha is 0.7. That is the dampening factor. And then finally, the FT. Before you can have T plus 1, FT plus 1, you must have FT. Okay. But if you don't have FT, then you know what you will represent it with. But if you have FT, you put it, that is a previous or previous period forecast. The F means forecast. So we need to calculate this simple exponential smoothing forecast. We need to do that. How do you do that? Well, using this formula, we need to find for...
Sorry, sir, please, the 1 minus alpha is what?
Is a dampening factor. Dampening.
Okay.
Something smooth, that is the alpha. And then the 1 minus alpha is a dampening factor.
Okay, thank you.
So if I want to, first I need to know my F1. Because we're about to do F2. F2 is the FT plus 1. Okay, so I need to know my F1. Because this one that you see here is the current, the 1 plus 1, which is F2. But the good news is that we have been told in the question that what? You can tell us. I mean, you all have the question. I don't want to scroll up. We have been told in the question that what?
F1 is equal to D1.
What does that mean? Think small. What does that mean? It means that if you don't have to calculate for, current forecast, use current demand, whatever number that is for the current forecast. Now let's go to the question and see the current demand. Okay. What is the value of the current demand? What's the value? So F1 is D1, and that is equal to what? 4 to 6. That's it. So we already now know our current forecast. Don't forget the formula. Don't forget the formula. Don't forget the formula. Okay. So we go back to the formula here. We know our current forecast. What we are now going to do is that we can now use that to find our F2, because the F2 is equal to alpha. Alpha is what value? My I is here, but I'm asking you the thing to write. 0.3. So it is 0.3. And then the current demand, DT, we already know that to be what?
4 to 6.
Are you guys with me? Then you do plus 1 minus alpha, which is 0.7. Multiply by, and again, check the formula. Your I must be on the formula. Multiply by FT. What is the value of FT? What's the value of F1?
4 to 6.
It's the same 4 to 6. So that's what was given to us. So now we can calculate F2. Using this, we can easily find F2. When you work it out, you're going to get 426.
Yeah.
Same thing. Okay. So this also happened to be the same as the first one. F1 is the same as F2. Okay. Now we go to F what? 3. And again, don't be scared, don't be worried. It's the same thing. First, you write your F.3 into bracket. Remember, it is DT. Your I must be on the formula. DT means a current. Okay. DT. Okay. And that will be the value that you have in the table that you were given. What was the value there? D2. Sorry?
451.
451. 451. So you must go there and then go and get it. Then plus 0.5 multiplied by F2. What is F2? Because remember, it is a forecast. Because when you're in year 2, you are forecasting for year 3, which is what we are doing. Okay. What is it? 426. So you put in that same 426. And when you do that, you're going to get 433.5. Then you go to F4. By the time you get to F3, your brain is settled for the thing. Okay. Now, you take your 0.3 into brackets. The current demand is 405, isn't it?
Yes, sir.
For year
Yeah.
3. 405. Then plus 0.7 into bracket the forecast for F3, which we just had, which is 433.5. When you do that, what do you get?
424.95.
Very good. These petty things, if you do it, you will learn it here today. You will not have to learn it again. When you get into the exam room, all the ideas will come. Yes, Yasin.
So, say, please, now back to my question. So, when I was watching the YouTube video, right, I realized that for F1, you put 0 there, but there was a figure there. So, my question was, why is it that we put 0 there? Because I remember you also said that usually the forecast for the current period is the same as the demand for that period.
I
But
don't
over
remember
here,
that video.
sorry,
I don't
you don't
remember
remember?
that. No.
Okay, you did. Okay, well, I think the question I wanted to ask, based on what you've solved here, it has been answered. But
Good.
if you are saying you don't remember that video, I'll just stick to this one.
Yeah.
Thank you.
Okay. So now we've been able to do for F4. We can now go to F5. So F5 is going to be 0.3 into brackets. What's the value you have for F5? Is it 370 something? 370
372.
372. Then you do 1 minus the alpha, which is 0.5, 0.7. Then you multiply that by what we just had. Okay. 424.95. And then you get your value for forecast for period 5. Okay, what do you get? Oh, 9. I have over 100 people here. Nobody's calculating along with me. Like somebody is not even having the
409.
calculator.
09.065.
Obi on one kasad, you know. So, but you have to really open your mouth and say something, because that is every cell in your body is eavesdropping on your internal data. When you don't understand, you ask. You don't switch up and say, are they with the bedding? That thing won't solve it. And a bedding, no. Okay, you have to say that we are cracking it. You don't understand, you ask. You ask immediately so that it doesn't pile up. Okay, now we go to F6. Forecast for period 6. You get 0.3 into bracket. If you check the value is 390 plus 0.7 into bracket. I could have just given you the answers without showing you working so that you can understand. 409. Then you do your forecast. What do you get?
403.3455.
Oh, 3.3. Very good. So that helps you to be able to achieve all the forecasts that you want to achieve here. That is for the F's. But when you go to the question carefully, the question was develop an adjusted exponential smoothing, not develop a simple exponential smoothing, but adjusted. Now, the adjusted will require that you use this formula rather. Okay, but you will need what we just done. You use this formula. That's adjusted. So keep these answers somewhere because you're going to deal with them. Okay, so now I'm going to use this formula in the process to find the adjusted. Any questions so far? Any question?
Good evening, doctor.
Yeah.
Yeah, I'm just looking at the figures with the enrollment, but the forecast were having some decimal places in the number, like 4 something 0.95. This is talking about enrollment. Wouldn't you run it up to whole numbers?
No, leave it as it is for now.
Okay.
Leave it like this one. Okay. Yes, Rita. Yes, Rita. Hey. Is Rita here? Okay. So the seasonal, the exponential, what do you call it? Just an exponential smoothing forecast. For you to be able to do that, you need something in addition to these levels we just calculated. We just calculated the levels. Now, if you check the formula very carefully, the formula is what I've just circled here. Okay. The formula requires what we just did now, and then you just need a time trend attached to it. And interestingly, the time trend has also been given, okay, for you. So you just have to use the given time trend to be able to continue your calculation that you want to do. Yes, Mercy.
Please, what did you say the name of the formula is again?
Which one?
The number 9, the one you circled.
The adjusted exponential smoothing forecast.
Okay, thank you.
Okay. So this one requires, so an adjusted exponential smoothing, the A is adjusted, okay? And the exponential smoothing forecast is the one we already know. But this one is unadjusted. So all you do is that you take the one we've done already, and then you add a time trend to it, and that's it. For each one, you're going to do the same thing. AF1, AF2, AF3, up to AF6, just as we did the F1, F2, F3, up to 6. But that one, for you to be able to do it, you need to just open your eyes a little bit because it requires that. So first, the time trend. Look at the time trend carefully. The time trend, you have to start, go back to the question. If you go to the question here, the reason why I'm teaching you this is that it might be your easiest one. I don't like to. So you say that T2, this question was given to you that T2 is 2. What does that mean? He's saying that T2 is 2 means that you got to start from where? You got to start your adjusted exponential smoothing forecast from where? From which period?
Period 2. Period 2.
No. If T2 has been given to you, then you have to start from where? Because you are forecasting.
3.
3. You are forecasting for the next period. I want you to let that sink in. So even though that one is plenty, you're not going to calculate for T1 and then T2. So we first have to calculate for T3, the time trend 3. Look at the formula for the time trend 3. That's where we are starting the calculation for the one I've highlighted here. You're going to calculate for this. So how do you calculate for T3? Oh, it's simple, crowd. It's simple. Very, very simple. So T3. Look at the formula. The formula requires that you know beta. Was beta given to us? Yes. What was the value of the beta?
0.20.
0.2.
0.2.
Then the next thing is the FT plus 1. FT plus 1 means that since we are in T3, okay, then the T plus 1 will be what? Since we are in T3.
T plus 1.
FT plus 1.
Period 4.
No, it can't be period 4.
It's period 2.
Oh, come on.
Period 3.
T3. Yeah, so our period, our FT plus 1 will be F what?
F3. Minus F2.
Okay, it's F3. What do you mean? Jamano, so no man go and now kakra no pokra. Hey, maybe sakra. You know. So you just need your F3 value. So go check your F3 value, and you see that your F3 value was what?
433.5.
Then you do minus the current. which in this case becomes what? F2. And what was the
Okay.
F2 value?
426.
426.
See, if your I is not on the formula, you will not be able to write it in. Then after that, you close the bracket. Then you bring plus, then 1 minus the beta. 1 minus the beta is 0.8. Then into bracket, the current time. And since we are doing for T3, then the current time will be what?
Therefore, T2.
T2.
It will be for the period 2. And that is the value of what? 2. So it's just the value of 2. So you just find the answer. You do 433.5 minus 426 plus 0.8 multiplied by 2. When you do that, you're going to get something like what?
3.1.
Very good. So now that you have T3, look at the formula. And the first adjusted exponential smoothing forecast, the first one here is going to be the F3 plus this T3. You get it? This F3 plus, but it would be nice rather to calculate all the T's and finish. Trust me, that's usually the best. Instead of when you get one, then you go and calculate the other. When you get one, you go and calculate the other. Because you already have the if you check the formula here, okay, everything here, you have it already. Everything. Watch it. For this one, you have them all already. So they are here too. So all you got to do is you have to have all of this. And then once you finish, we add the 2, we add the 2, we add the 2, and then we are getting adjusted, just like that. So it will be nice to continue to T4. So let's do T4. T4 will be 0.2 multiplied by what? Let me see whether some of you are cracking it now. 0.2. Sorry?
424.95 minus 433.5.
So you get 424.95 minus 433.5 plus 0.8 into bracket what? That one is easy.
3.1.
3.1. So we just calculated it. When you do that, what do you get?
0.77.
Very good. So you get 0.77. Let's go to T5. So T5 is going to be 0.2 into bracket 409. Okay. You just go and check T5, what we had there. For the F5. If you go and check for F5, you know, 409 minus 424. The one just before, the one we just have here. 424.95 plus 0.8 into bracket what?
0.77.
Exactly, 0.77 we just have. And when you do that, it will give you a negative value. Negative 2.574. You have to check it out. So that is your T5. And then the last one is your T6. T6 will require the same 0.2 into bracket 403.3 minus what we had before, 409. Okay. Plus the 0.8 into bracket what we just had, negative 2.574. And when you do that, you get negative 3.2.
3.19.
Yeah, 3.19 or 3.29. So
There is
on the basis of
3.19.
yeah, Let me just keep your 1 9 for you. So now, 9 o'clock is not right, but So now we are ready to calculate your adjusted exponential proof smoothing because you have all the necessary values that you need. So let's start with the first one. Okay. What is our AF2? AF2. Well, from the question, if you check it carefully. Oops. Okay. Yeah, Belinda.
Yeah. So please, what does the negative figures mean?
What are the
negative values, the ones for T5 and T6?
Their previous periods. We are only calculating previous time trend. It's a trend that can be positive upward, that is positive. A trend that is negatively sloping, that is a negative value. It's a trend.
Okay.
When something is going on, suppose inflation is coming down, that's a negative. Okay. So the rate of movement is negative. That's a trend. So the negativity is showing the trend. The positivity means that the thing is going up. Okay. Let's go to the AF2. So the AF2 will be the first one. Oops. The AF2 is the first one. How do you calculate the AF2? The AF2 is going to be, remember, it is always the F plus the T. The F plus the T. What was the first F for period 2? It was, go and check the data. We use the 426 for it.
Yeah.
So it is 426 plus the trend. What was the trend? 2.
2.
Yeah, go and check. The trend was 2. So that one is what? 428. We are done.
428.
Then the AF3. If you check the value we had, that one is this one up here. So it's a 433 because we are using the F3. So that is 433.5 plus, what was the time trend?
3.1.
Yes, Sarah.
Yes, Doc, please, instead of doing it this way, could you like after you're done with your FT plus 1 and then the TT plus 1, could you put this in a table and then now come and do your the FT
Yes.
plus 1 so that you don't have to do, will you still be given the same marks? Like if you don't have to do the FT additions separately, or you can just do it from the table.
Yeah, you can.
Okay.
You can do it from the table. Okay, so you do 3.1 and that will give you 436.6. Okay. That leaves us with AF4. Okay. So you can do the AF4. What is our AF4? If you do the AF4, since you have the values, it's easier. It is 424.95 plus 0.77. That's the time trend, which gives you 425.72. Then you go to AF5. AF5 will be the 409, but it was minus. Don't forget the time trend was minus. So 409 minus 2.574. Okay, so that will give you 406.43. And then the last one, AF6. That is a 403.3 minus, go and check this value here. It was minus 3.19. So minus 3.19. That will give you 400 something, 400.1 or something, or 390. Check it in.
400.15.
So you've been able to calculate all of these, okay? And then, like she said, you can put it in the table, okay, to make life easier, okay? You can do that. You can understand and appreciate. I'm teaching you. That's why we have gone slow. If you are doing it, you go fast. So you get 1.5 marks, 0.5 marks for each of the, if you draw the table, you get a mark. Apart from your calculation, you get marks for each calculation you've done here. Let me tell you something very funny. Each one here is 0.25 mark. Okay. Each one that we've done here. So this one is 0.2. Oh, this. Okay. This T3 is 0.25. This one is 0.25, 0.25, 0.25. It's not half. Oh. It's not even half. 0.25. My father was who forced you? You come and collect 0.25 small before you get one. I don't want to be in your shoes. So that is a masterpiece of this. Now, let me just go to the other subsidiary questions that were asked here. And then we are done for today. Because after calculating, the question says something. It says, develop an adjusted exponential smoothing, blah, blah, blah. Compare it to a linear trend line, okay? So he didn't want you to go and calculate a new linear trend line. A linear trend line has been given to you based on the forecast accuracy. And the forecast is MAD. So this is an interesting thing. So first, you need to calculate the mean absolute deviation for what do you call it? For the linear trend line. And then, of course, for this one. Now, what is the formula for the MAD? Who knows? Yasin.
This is the sum of demand minus the sum of the current forecast divided by N.
Yeah. Indeed, you are supposed to be giving. It's not really fair, say. You are not giving that. So it's a sum of what? Demand divided by the sample size, isn't it?
Demand minus the forecast.
Yes. Demand minus. I mean, the sum of, or the forecast minus the demand, whichever way it is. But demand minus forecast. So we go to each.
I wanted to clarify something. It's divided by N, but again, in that video, I remember you said we should do N minus 1. I just wanted to confirm, are we doing N or N minus 1?
Do N.
N. Okay. Thank you.
You're asking the right questions. Yes, Daisy.
Sorry, sir, can you go by the formula again?
Oh, how did you say the formula? It's your friend. My dear, tell her.
Is the sum of the demand minus the sum of the forecast all over.
When I write it, it might be better. MAD is equal to sum of the demand minus the forecast divided by N. So you have to take the first one and then you do. Now, the first one, the actual was enrollment. The enrollment was 426. Do you know that? Check it. You all have the question. So it's going to be 426, which is actual minus the demand in the table form. The demand was nothing. If you can check that period, demand was nothing. Okay. So there will be nothing for the difference. There'll be nothing for the difference. Then the second one was 451. Go and check that. 451. And then the forecast was 428. So the difference would be what? 451 minus 428, 23. Okay. And we take the absolute value. All of them will take the absolute value. So I'll take the absolute value straight away. Then the next one was 405. Check the table. You see all this. Okay. Minus 436. Go and check. We had 436.6.
31.
Okay, but let's take the absolute value. So that is 31.6.
Yeah.
Then the next one was 372. 425.72. Find the difference. The difference will be negative. So we take an absolute value,
53.72.
72. Then the next one is in 390. Check it. 406 is the forecast, 0.43. It will be negative 16. So we take the absolute value, positive 16.43. You got to calculate these. And the last one is 347. And then we had 400.15. Is that it? And then we had a negative value whose absolute value.
53.15.
So once you have all these, now we are going to add these ones. The D minus the forecast. You add all of them together. Go and add all of them. When you add all of them together,
it gives you 177.85.
Yeah. And then you divide that by 5.
That's 35.57.
Yes, Daisy.
So because I think you're rushing. So like way behind.
So you tell me why you're behind. Then we'll wait for you.
But after the calculations, when we ended at the 531, I don't know what else you did afterward.
What I did is to add them all together. Add these ones all together, which is what your friend did, and divide it by 5. Was it being divided by 5 or 6? Oh, 5, yes, because the first one had nothing. Did you get it? You divided by 5.
Okay, thank you.
Yes, it.
Doc, please, so for this one, the answer is 35.57. But my question is, you mentioned that for like forecast errors, we usually prefer a smaller error, like a smaller number. So is there a range that you would say that like maybe from 1 to 10?
No. This one is going to be compared with another one. Then you take the smaller one.
Okay.
Sure. Yeah. So this is the forecast error for the one we just did, which is the adjusted exponential smoothing forecast. Now we are going to do the same thing for the trend line. That's what the question was saying. The question was saying that we should do the same thing for the trend line. So where is the trend line? You check the trend line. The formula was given to you. So let's go up here.
Hello, sir. Please, before we move, the sum for the formula MAD is sum of DI, which we calculated to 177.8 minus FT over N. I've gotten the sum of DI and then the N, the minus FT.
You do the minus before you sum. You don't sum separately. You do the D minus F, D minus F, D minus F, D minus F.
Okay. All right. Thank you.
Exactly. That's what I was doing with her.
All right. Thank you.
Okay. So now the question on your screen, it says that compare it to the linear trend model, and the linear trend model was given to us. Okay. Based on this MAD. Indicate which one is more accurate. So the question is that, how do you do the trend line? Remember, the trend line has been given to us here. Okay. The trend line is what? It's this one here. That is a trend line. Okay. 459 minus 17.46 T. So T here means whatever you see T, you put in what value? The year at the top. Okay. So the first one, we put in the year, which is what? 1, isn't it? So whatever you see T here, you're going to drop this 1. So you get 459 minus 17.461. And when you do that, you're going to get the predicted Y value, like the forecast. That's a forecast, actually, because time trend is just using this equation to do. So that will give you a forecast of 441.61 or something. Please, I'm just doing a few of them because I know you can do the rest. Hey, it's not, this one is 5.
5-4.
Yeah. It's 5-4. Then the second one will be 459 minus that same 17.46 multiplied by 2. That will give you 424.08. Then the third one, which is the F3, will be that same 459 minus, it's the same thing. The only thing is that you are multiplying it by 1, by 2, by 3, by 4. So when you do the third one, you're going to get 406.62. Then the last one, okay, let me do all. 389.16. The next one will be 371.70. Then 354.24. Copy it. Yours is just to copy it. That's it. So once you have these, what do? These are the forecasts. Now you come and these are your F. Okay. Then you come and do your D minus F for each one of them. The D minus F. What was the D? If you check the first one, the D was the 426. So the first one would have been 426 minus the forecast. And the forecast was
23.
Was it 23? This was the first period.
441.54.
No, it can't be 441.
That is 426. The same 426.
Oh, wait. The first one. It should be 441. It should be 441. So.
It's 441.51. Okay, 4.
441.5. And then when you do it, you get a minus, isn't it? And then you take the absolute value.
Yes, sir.
Then you do for the next one, you get a minus. Then you take the absolute value. Then you do for the next one, you get a minus. You take the absolute value till you get to the end. Once you get to the end, you now sum them, just like the previous one. And you calculate your MAD. You calculate your MAD. I don't want to take much of time. Time is gone.
So please, where's the 126 coming from?
1, 2, what?
Okay, it's 426. I see 126.
There is no 126 here.
What's that calculation for? The 426 minus 4.54. What's this calculation?
Discuss among yourself. Discuss among yourself.
Check the first figure. 426. 1 over 426. That's why he picked the 426. Then since we did the first one, that is 459 minus 17.46. Where the T is, you put the 1 there. So when you subtract, you get 441.54. So he picked the 426 minus 441.54. Do you get my explanation?
Yes, please. But what are we finding exactly?
We're finding the sum of D minus F. That's what we are finding. So that's why they are picking the demand, which is the 426, minus the forecast for that period, which is the 44.54.
Thank you.
Doc, please, have you closed? Hmm. Hello, Doc.
Doc, please,
I'm
if you
sure
are speaking, I'm muted.
I'm sure he's doing something. He says that we should discuss among ourselves, but we are done with the discussions. So let's wait for him.
So I have a question. So when you finish doing the D minus F, this time the N, will it be 6 or it will be 5? If you are finding the MAD,
It will be 6.
it will be 6. All right. Thank you.
The thing is,
Six.
that's looking on the crowd. Hey,
It will be 6.
do basa, basa, basa.
They are not what?
But I was thinking we are going to start from the yet.
And then we have to watch the video like 3 times so because hey,
Asemo.
And then is the crown.
It's
And
only
in your
as you
face. Go and
understand.
watch the video. You will pass.
Was there into your face, what?
Mm.
I did I am where I need to see.
And that's some good sister.
All right, all right, all right, all right.
He's still recording, you guys. Yeah.
All right, let's wrap it up.
Talk about passing in a mamusru. You best you ever pass
I think let's wrap it up.
Yes, true.
Can you hear me?
Yeah, we
Yes.
can.
Okay.
Yes, please.
So
Yeah, we can.
when you calculate the MAD for this one, you're going to get something like 14.46. Just put it down. Approximately.
Yes.
You got that?
Yes, sir.
Oh, fantastic. I love it when some people do it. So once you get that value, please just hold on. I'm not back one. Back. All right. So what you have to do is you now compare the two. So when you look at the linear trend line, the model has an MAD of 14.46. And then the other one has the exponential smoothing model. That one has an MAD of, was it 35.57 we had?
Yes, Doc.
Good. So now which one do you think is better? Is
the linear trend.
14. Because the linear trend line gives us a smaller error than the other one. Okay. So the smaller MAD is better. It gives you a better accuracy of the model. That's all. 25 over 25. Ladies and gentlemen, that brings us to the end of the entire Kabudo. Now, of course, you may have a question. So let's wrap it up.